During the Cold War, the CIA faced a massive and deeply fortified adversary in the Soviet Union. Gathering reliable intelligence from inside its borders was incredibly difficult. The peak of 1960s surveillance technology looked like this. Agencies relied on spy planes flying tens of thousands of feet above their targets, or satellites restricted to the vacuum of space. But from those altitudes, capturing highly detailed ground-level information is impossible. To eavesdrop on a conversation or identify specific equipment, the agency needed assets capable of getting inches away from heavily guarded targets without raising suspicion. Developing mechanical drones that small and quiet was decades away, so the CIA looked to nature. They realized the ultimate stealth vehicles had already been engineered through millions of years of evolution. Animals possess an inherent psychological advantage over human spies or metal machines. People simply do not notice them. A bird on a windowsill or a stray cat wandering down the street gets completely filtered out of human awareness, even in the most secure environments. Declassified documents reveal that the CIA's attempts to weaponize animals were born from a strict, calculated logic. If human technology couldn't bypass Soviet security, perhaps biological hardware could. One of the CIA's primary targets was the complex network of shipyards in Leningrad, where the Soviets were actively constructing nuclear submarines. They needed high-resolution photographs, requiring an approach much lower than a plane. Pigeons solved the altitude problem. A pigeon can comfortably fly about 100 feet over a target, day or night, and regardless of the weather. More importantly, they possess a unique homing instinct, allowing them to consistently navigate back to their loft from entirely unfamiliar drop points. This diagram illustrates the custom-built payload. The CIA's Office of Research and Development created a miniaturized 16mm camera strapped to a lightweight leather harness. The entire rig weighed just 39.5 grams, keeping the bird aerodynamic while the camera automatically advanced the film. Handlers developed ABC training. Point A is the release, Point B the target, and Point C the loft. By rewarding flights to B, then removing that midway reward, the pigeon learned the only way to get fed at C was flying over B first. Deploying them required extreme operational secrecy. The CIA modified mundane vehicles, like this Volkswagen Beetle. Agents cut a trap door into the floorboard. Once parked near a target, they could secretly drop the pigeons through the hole to take flight from underneath the car. But pigeons aren't machines. Some simply flew away. Others were killed by hawks or struck by cars while flying too low. Relying on a bird's navigational instinct meant introducing massive, uncontrollable variables into the intelligence-gathering process. Capturing imagery was one thing, capturing audio was entirely different. If enemy agents conversed outdoors, the CIA needed to record it without tipping them off. Microphones in the 1960s recorded audio indiscriminately. If you tried to bug an outdoor conversation from a distance, the equipment would pick up the wind, the traffic, and the rustling leaves, rendering individual voices completely inaudible. Enter Acoustic Kitty.
The anatomical structure of a cat's ear naturally focuses on specific sounds, filtering out ambient noise. The CIA realized a feline's auditory processing could solve the outdoor recording problem. To extract that audio, they subjected a cat to millions of dollars in invasive surgery. Veterinarians implanted a microphone into its ear canal, hid a transmitter and battery pack beneath its skin, and wove an antenna into its tail. Meanwhile, at a remote Navy facility on San Clementine Island, they tested a second proximity asset, a raven named Duda. Selected for extreme intelligence and object recognition, Duda could identify specific desks, open drawers, and carry heavy file folders. The tactical plan for ravens involved an agent aiming an invisible laser at a specific target, like an open windowsill. The bird would take a disguised listening device in its beak, fly to the laser dot, plant the bug, and wait for a signal to retrieve it later. In the field, reality collided with biology. Even if Duda the raven planted a device perfectly, he would regularly get into dogfights with local birds, and handlers quickly learned that Acoustic Kitty would abandon its mission the moment it got hungry or distracted. Possessing a superior biological sensor meant nothing if the animal's natural instincts overrode its CIA programming. The agency also sought biological solutions for naval operations. Approaching enemy submarines in the open ocean without triggering sonar was nearly impossible for human divers. This led to Project Oxygas.
Dolphins have highly sophisticated echolocation and remarkable intelligence, making them ideal candidates for deep-water sabotage and intelligence gathering. Initial tests were highly promising. Handlers successfully taught dolphins to carry simulated explosive devices and attach them directly to the propellers of anchored boats. But a unique flaw emerged. Dolphins are intensely social animals. They performed these complex tasks specifically to please the trainers they had bonded with. When handed off to unfamiliar, undercover field agents, the animals simply stopped cooperating. Project Oxygas exposed a severe paradox in the CIA's biological hardware. The higher the intelligence of the animal, the more complex its social behavior becomes, making it practically impossible to program. By the mid-1970s, the declassified documents show these animal projects fizzling out. The agency accepted that wild animals could not be operated with the reliability of a machine. Millions of dollars in engineering and operant conditioning were regularly defeated by the most mundane variables. Traffic patterns, hungry hawks, and a simple lack of interest rendered the programs operationally useless. Yet the core premise, that nature has already perfected stealth and sensory technology, remains entirely valid. Today, the quest to weaponize biology continues. Modern initiatives bypass the unpredictability of wild instincts altogether. DARPA has developed neural probes that plug directly into insect nervous systems to remotely control flight. Other programs are mapping the sounds of snapping shrimp to use as living underwater alarm sensors. The Cold War's animal spies failed because intelligence agencies couldn't override nature, but they paved the way for an era where the line between wild biology and military technology is steadily